Okay, problem number 1. Part 17 of our review. Part 16. What did I say? 17? My bad. Okay, it says quadrilateral QRST has these vertices. What is the length of RS? Well, it basically just tells you how to do it right in the problem. It says what's the length. Anytime we're finding the length, we're going to use that distance formula. So remember, of course, the distance formula is this. Square root of, and we do x minus x squared plus y minus y squared. Okay? So if we're supposed to find, what did it say, Q, RS. We're supposed to find RS, so focus on these guys. So RS, so let's just do the formula. So x minus x, so that's going to be 6 minus 4 squared plus, now y minus y. So I'm going to do 6 plus 8, because minus a negative 8 is the same as plus 8. Okay, don't forget that, plus 8. Type all that into your calculator, and what did you get? 10 root 2. So if you didn't get 10 root 2, you typed something wrong. Any questions? Okay, that was problem number 1. Problem number 2. The coordinate grid below shows a sketch of a silver pendant. Each unit represents 10 millimeters. That means whatever we get for units, we're going to have to multiply it by 10 to get millimeters. What is the shortest distance from R to HG? Well, if you look at the picture, come on. The shortest distance from R to HG is going to be the perpendicular distance. No, I mean they want an actual number. But the distance I just highlighted, that is the shortest distance. It's going to be the vertical line. So as far as the units go, we could just count the squares. How many units is it from R to T? It's up 5, down 5. So what's that?
5, 10.
10. Okay, so it's 10 units. What would that be in millimeters? That's going to be 100 millimeters, because we had to do 10 times 10 because it said each square was worth 10 millimeters. So that's why we had to multiply by 10. So 100 millimeters from R to T. Now, then we're supposed to say, oh, I kind of put that on the wrong one, didn't I?
Yeah.
Okay, no se preocupen. Shablau. Okay. All right. Okay, so we're supposed to find how many millimeters longer is RT than ST. So we already have RT. So let's find ST. Now watch this very carefully, you guys. I could use the distance formula again, I suppose. But I'm not going to. Because if I want to find ST, the easiest thing to do is just to look at ST as hypotenuse of this right triangle that I'm drawing in blue. Okay? ST is the hypotenuse of this triangle. So let's just use the Pythagorean Theorem. What's the horizontal length on this triangle?
4.
That's 4. What's the vertical length?
4.
3. 1, 2, 3. So a lot of you have memorized, because this is such a common example, a 3, 4 what triangle? A 3, 4, 5 triangle. That's the most common Pythagorean triple that you'll ever see. So if you already know that's going to be 5, great. If you were sitting there and you would not have known that, then you would need to solve the Pythagorean theorem. So you would sit here and go, a squared plus b squared equals c squared. So that would give you 16 plus 9 equals c squared. So that's 25 equals c squared, square root. So therefore, c is equal to 5. Okay, so that's 5 units, which equals how many millimeters? That's 50 millimeters. Again, we had to multiply by 10. So we're supposed to tell how much longer the first one was compared with the second one. So how much longer is it?
50 millimeters.
Yeah, the first one was 100 millimeters, and the second one was 50 millimeters. So how much longer? You would just subtract. 100 minus 50 is 50 millimeters longer. Okay, so that's the answer to the question. All right, so that was number 2. Okay, let's go down to number 3. All right, the coordinate grid shows line segment CD. Point C is the midpoint of segment BD. That's weird. Let's see. Point C is supposed to be the midpoint of segment BD. Well, how could that be the midpoint? It's all the way over here on the end. Well, that's because the point B is not shown. So let's just estimate if point C is the midpoint, that means point B must be over in that area somewhere. So if I make this segment, okay, now I can see that point C would be the midpoint between B and D. Our job is to find the coordinates of the point B that we don't know over there. We're going to use the midpoint formula. Now, Maurice has too. We used to do this back in the day, and most of you guys really struggled with it. A few of you owned it, most of you didn't. So you have one more shot at it. So really pay attention. Okay? So point B, I don't know what it is. We're supposed to find it. So I'm going to call it XY for now. Now, point C, I can see what the coordinates of point C are. It is -3, 0. And I can see what the coordinates of point D are. That's 3, -3. Now, here's why I'm doing that. The midpoint formula. Really, the midpoint formula is just all about taking averages. Focus on the x values, you guys. If I take the average of the x values, it should give me the middle x value. So the x values are x and 3. If I take the average of them, I'm going to use -3. But -3 is the middle, so that should be the answer. Okay, the average of the two endpoints should give you the middle as the result. So when I set up my midpoint formula, it's going to be like this. The average of the x and the 3, the two x values on the end. And I'm doing the average, so I'm going to divide by 2. The average of the two ends should equal the middle. So this should equal -3. Siobhan, do you understand where I got that equation from? Okay. Understanding the setup is the hard part. Solving is the easy part. What will be my first step toward solving? Times 2. Who said that? Yeah, that's Maria back there. She said, let's multiply by 2. Always multiply by the denominator if you've got one. So multiplying by 2 is going to cancel those out. So that's going to leave me x plus 3 equals -6. Subtracting 3 from both sides. X equals -9. So far, that tells me I've got -9 comma something. Now I'm just going to do the same thing with the y values. Let me switch over to, let's say green. Yeah, yellow is too hard to see. So now I'm doing the y values. So the two y values on the end, the y and the -3, if I average them together, they should equal 0 as a result. So, tell me the equation, people. Correct. Y plus -3 over 2 should equal 0. Again, we solve this the exact same way. Multiply by 2 on both sides. Those cancel out. That means y plus -3 equals 0. Add 3 to both sides. So that gives me y equals 3. Okay? And that completes it. So this would be the ordered pair for point B. -9, 3 is B. Yes?
How do you know which one to add to and equal it to?
That's a good question. When we find the midpoint, we're taking the average of the ends, and that should equal the middle. So, when I did the y values, for example, I added up the ones on the ends of my segment, the y and the -3, and that should equal the middle one. So that's why the 0 is over here. Okay? Alright, so that was number 3. Look at number 4. On this coordinate grid, the library is located at point T. Let's label this off as we go. Alright, point T is the library. So go to point T and write library. True, true. Okay, what else we got? The music store is at point S. So music store. Whoops, why did I do that? Okay, that's the music store. What's this other one?
Pet store.
The pet store is at point R, so pet store. Okay? Now, what are we supposed to find here? Luckily, each grid line represents 1 mile, so we won't have to multiply by anything. How much farther is the music store from the library than it is from the pet store? So we're talking about music store to the library as opposed to the pet store. So these are the two distances we're finding. The distance from the music store to the pet store, and the distance from the music store to the library. Obviously, the distance to the library is longer. The question is, how much longer? Okay? Now, one of these two distances you should be able to just look at and know in seconds without any calculation. 8 is the distance to the pet store. How did you get that so fast, Edgar? Just add the squares. Okay? Look at the bottom. 1, 2, 3, 4, 5, 6, 7, 8. The distance to the pet store is a length of 8. Okay? But we're supposed to compare it to the distance to the library. That's the hypotenuse. It's diagonal, so we can't just count. So maybe we'll have to do the Pythagorean Theorem, say. Okay? That's my guess at this moment is Pythagorean Theorem. If I'm going to do that, sure. If I'm going to do the Pythagorean Theorem, I'm going to need the other leg of this triangle. Can I get that pretty fast? John said 8. Again, we just count. And then look at that. Edgar says, wait a minute, we're not going to have to do the Pythagorean Theorem after all, will we? The only way it's going to be 8 and 8 like this is if how many degrees is this? This must be a 45, 45, 90 triangle. So we can immediately use our skills from the pattern. If both of these are 8, what's the hypotenuse going to be? The hypotenuse is going to be 8 radical 2. So that turned out to be really quick. We need decimals, so I hear decimals coming from Siobhan. One more time. 11.3. So we are supposed to compare these two distances to each other. we're asked how much longer is 11.3 as compared with 8. So what are they really asking us to do? Subtract. So we just do 11.3 minus 8. So what do you get?
3.3.
You get 3.3. Oh, and this is multiple choice, yes? Alright, I love it when it's multiple choice because you can just look and see, oh yeah, there it is. Okay? So number 4 was A. We did 11.3 minus 8. Because our goal was to find, it said how much further is it to the library as opposed to the pet store. So we had to subtract to find out how much bigger it is.
Can you go to number 3 real fast?
Sure. Yes, we do have an EOCT, Maurice. All right. So, number 5. Wesley is walking his dog along High Street. He wants to go from High Street to his house at point T. Here's a picture of what's happening. All right, so John, while I'm over here, let me add on to Maurice. Really? That's what I say to your comment from earlier. And McD. Come on, people. We already have a short period, so I don't have time for this behavior issues. Please act quiet. What happened to my screen? What's happening? Okay, I'm good. I think I'm good. I'm all in the wrong thing and stuff. What's happening? Okay. Wait, what happened? Okay. So here we are walking along High Street. And his dog is not going to walk across this area, so he's going to have to carry his dog. So he wants to know what at what point he should turn and start heading towards home. That would be the shortest distance. Where along this street is going to be the place where he needs to turn? Is it here? Or y'all probably can't see it. Is it here?
No.
Is it here?
No.
Is it here?
Yes.
Yeah, this is the spot where he's going to have to turn, okay, and start heading home. That is 8,7. Is this one multiple choice or? Yeah, okay, so that's why the answer to that one was C. Yes, muy fácil. Okay. Look at number 6. My friend. We just don't know what time we're going to get out because who knows what they're going to do with the bell schedule.
We're getting on 11:19.
No state.
Okay. But they delayed the bell.
That's because somebody had.
All right, looking at number 7. Line segment CD.
Wait, what about square number 6?
Oh, wait, see, I was thrown. All right, we have 3 vertices of this parallelogram are given. We're supposed to find the coordinates of the 4th vertex. Okay? Now, here's a strategy that I would like you to use. The easiest thing to do would be to graph these. But I did not provide a graph for you for this particular problem. But what could you do as a way of working around that? Probably the best thing to do in this case would be to use the graph from another problem. So I want you to use that strategy on the EOCT. The EOCT is one of those tests where you have a booklet that you're allowed to write on. So there will be graphs all over the place. So even if they don't give you a graph for a problem, find some other graph that you're finished with and use that graph to do the problem. That will help you. So that's what we're going to do right now. So one of our points is at 0, 0. So let's graph that. We have another point at 6, comma 10. So that's right here. Let's graph that. We have another one at 7, comma 0. That's right here. We're supposed to find the fourth corner of this parallelogram. Can you guys see that
The midpoint.
it's going to be somewhere in this area, somewhere around in here is where it's going to be. It's just a matter of nailing down exactly where it's going to be. To me, the easiest thing to do is just to use the slope. Okay? Look at the segment on the left. Look at the segment that I'm drawing right now. That would be one side of my parallelogram, yes? Let's look at the slope of it and see what we've got. What's the rise and what's the run? What's the rise? It's up 10 and over, I think it's 6. Okay, so it's up 10 and over 6. If this is a parallelogram, the other side should have the same slope. So starting from this point down here at the bottom, I'm going to go up 10 and over 6. That puts me right here. What are the coordinates of this point? 13, comma 10. So that would be the coordinate of point C. Alright, and that's probably the quickest way to do it. Alright, now number 7. Now, line segment CD shown on the grid is the hypotenuse of a right isosceles triangle. Remember, this word isosceles, do you guys know what that word means?
Yes.
Two sides are congruent if it's isosceles. Alright, so they're asking us where the third point would be to build an isosceles right triangle. So just draw it. If I draw a right triangle from C to D, and it does happen to be isosceles like it said, so this would have to be the other point B. What are the coordinates? 3, 2. Okay, this would be 3, 2.
How did you do that?
Just make a rectangle.
Okay.
Okay? Why is there another point that I could draw?
Upside down.
Right, upside down. If I draw the other side of my rectangle, like this, that will also be a right triangle that is isosceles. So what are the coordinates of this other possible point B? -2, -3. Okay? So those are the 2 points that it could be. Any questions on number 7?
What's the other point?
-2, -3. Alright, let's look at number 8. The vertices of a quadrilateral have the coordinates that are given. We're supposed to know what it is. Okay? Now, do you remember when we used to make a chart for everything? That's what I want us to do. Let's make a chart. So remember how we used to do it? Let's just make a chart sort of like this. Leave space in it for 4 rows, because we have 4 sides of this thing. So we're talking about E, F, G, H. So let's just go in order. So we have EF, and we have FG, and we have GH, and we have HE. Okay? I just went in pairs in order around this quadrilateral. Now, what are the 2 measurements that I'm going to want to find? Distance and slope. If I have the distance and the slope, I can figure out what shape it always is.
How about sometimes we need a diagonal?
that was like extra. We can always solve it with distances and slope alone. If we want to get fancy, we could do the diagonals as well. All right? So I'm not going to do them all. I will leave some of them for you. But of course, if I wanted to find the distance, for example, the length of EF, how would I find the distance? Distance formula. Okay? So one more time, that's x minus x. So I would do, for example, 4 minus 2 squared. Then y minus y. So that would be 3 minus negative 2. So I'm going to put 3 plus 2 squared. And I could just type all that in my calculator. Did anybody already do it? Square root of 29. Okay? So that came out to be the square root of 29. Please make sure you're getting square root of 29. Now, imagine that we did this 4 times. And you, of course, should actually do it 4 times. But I know that it happens to turn out to be the same thing all 4 times. So in the interest of time, I'm just going to go ahead and fill this in. Okay? You actually do it 4 times in your packet. Now, is that enough information for me to know what shape this is? No, because what are the 2 possible shapes it could be so far? Square or a rhombus. That's why I need the slopes. Because if it's a square has 90-degree angles. How will I recognize 90-degree angles?
Opposite reciprocals.
Opposite reciprocals, Mr. Sawyer said. Okay? So let's do some slopes. Remember that the formula for slope is y minus y over x minus x. And the order does matter, so we can think y2 minus y1, x2 minus x1. And again, I'm just going to do one of these, and then I'm just going to cheat after that. So if I do the slope of EF, for example, the slope of EF, I'm going to do y minus y. So let's see. So that's 3 minus negative 2, or 3 plus 2, over 4 minus 2. So that's going to give me 5 over 2. So the slope of EF turns out to be 5 over 2. Now, if I did the same sort of calculation for FG, and again, you need to do the calculations and go ahead and show it for your packet. But in the interest of time, I will tell you that this turns out to be negative 2 over 5. So is this a situation where it's going to be perpendicular or not?
Yes.
Yes, these are perpendicular. Like Mr. Sawyer said, these are opposite in sign, and they are reciprocal to each other. Opposite and reciprocal. Therefore, they are perpendicular. Wait, stand by. This is also, GH would turn out to be positive 5 over 2, and HE turns out to be negative 2/5.
It is a square, sir.
So it is certainly a square. Everything is perpendicular here. So we get to say square. All right, again with the isosceles, okay? It says we have an isosceles triangle. And it says PQ is equal to QR. So I have 2 sides equal. So, for example, I could call this Q. That would make this PQ, and this could be RQ, because those are supposed to be equal. So that's just a diagram of what we're dealing with. Now, point P is located at 1, 1, so I'll label that. What else do I know? Anything? Oh, it mentions the centroid. The centroid of the triangle is 6, 2. Huh, that's weird. So the centroid, let's say it's in there, is going to be 6, 2. Wow, what in the world am I going to do? I'm supposed to find the coordinates of point R, because that's my question mark. The key is symmetry. Because this is an isosceles triangle, if I find the distance, let's call this point C for centroid. The distance to the centroid to point P and the distance from the centroid to point R, those should be the same. Because it's isosceles, it should be balanced on the left and the right. So we can find the distance from P to C, can't we? By using the distance formula. If we do that, and I'm talking about x minus x, so 6 minus 1 squared plus 2 minus 1 squared. Tell me the length of PC. Type that in your calculator and tell me. Okay, so that first distance is the square root of 26. Now, if we pick the correct point R, the distance from R to C should also be the square root of 26. So let's use our common sense and try to narrow down the choices instead of just going directly in order. Looking at the coordinates, what would be your best guess at which one of these looks reasonable to go in this area of the graph? See, I heard 1 and 4, 11 and 1. So we would just try each of those. Let's try 11 and 1 first. Okay? Let's say if we try 11 and 1 and check the distance. Okay? That, if we use 11 and 1, then RC would become, okay, x minus x. So that's 6 minus 1 squared. No, 11. 6 minus 11 squared. Do not leave without your other sheet. It does turn out to be radical 26. That's how we know that the answer is D.